The velocity v for the streamline flow of a liquid in a small uniform tube depends on the radius r of the tube, the density, and the coefficient of viscosity of the liquid. Use the method of dimensional analysis to obtain an expression for the velocity. Full stop. Whenever you are solving a physics question and you see full stop, always know that it is more like you having one part of the question, then what follows it is like a second part. So pay attention to the full stop. After that, we are given another part of the question. Then I said, given that V is equals to R squared P all over 4 coefficients of viscosity L times L. We should use this, they are telling us to use this equation to obtain an expression for the dimensionless constant in your expression of V. That is from, in your expression, the first part of what you got for V. So notice that in this case, we will remember that before we are given anything, they told us that we should obtain an expression for velocity using method of dimensional analysis. And method of dimensional analysis is simply to, first of all, remember the first rule of dimensional analysis, which says assume the dependent. What is the dependent here? The velocity depends on the, okay, which is V is the dependent here, and it depends on things like depends on the radius r, density, and viscosity. So the first rule is to assume the dependence to be equal to the product of the given variables, which is r, density, small letter p, and coefficient of viscosity. So, and once we introduce this equality sign in physics, we normally put k, that is the dimensionless constant. And obeying that rule of dimensional method, we always say that the dependence should be equal to the product of the given variables raised to unknown powers. Let's say the unknown powers here, we are calling it x, y, and z. So we must use this to solve for the dimensional analysis to get V using dimensional method, since the question asked us to use the method of dimensional analysis to get this. So when we are through, we'll now look at the second part of the question, where they said that after we've obtained using method of dimensional analysis that we should use what we got for V and get an expression for the dimensionless constant, which is k, using this thing that we are given now. So let's try to solve this. If you like, don't pay attention. So we know that V is equals to LT raised to power minus 1 equals to K. K is the dimensionless constant, which is the same thing as 1. 1 times everything is the same thing. So R is L raised to power X. Density is mass. Density, first of all, density is mass over volume, and volume is L raised to power 3. So density is ml raised to power minus 3. So I put it here, ml raised to power minus 3, all raised to power y. Viscosity, from our previous calculation, make sure you go back and check our video on viscosity. Our previous calculation, we got that viscosity is the same thing as saying having m L minus 1 T minus 1 all raised to power Z. That is viscosity for you. So now we need to distribute. So we now have, using distributive power law, we now have L raised to the power x. Then we have m raised to the power y, L raised to the power minus 3y, then m raised to the power z, L raised to the power minus 1z, t raised to the power minus 1z. Remember that all this is t raised to t minus 1. So at this junction, we'll do multiplication law. Let the right hand side, we'll collect all the L. Product law in indices. We add the powers x. This is minus 3y. Minus 1 times z is minus z. Then m is y and z plus z. T is just minus 1 times z is minus 1 z. So we have LT minus 1. The second rule of dimensional analysis, the second rule for the method of dimensional analysis is to know that on the left hand side we are supposed to have MLT, and on the right hand side we should have MLT. We should have equal MLT. We should have MLT and MLT, left hand side and right hand side. So since there is no M on the right hand side, on the left hand side we'll put 0, because anything raised to power 0 is 1, and if we have 1 here, 1 times everything here is still everything here. So let's bring down this one, L T minus. So on this side we have everything. So minus 1 is equals to minus z. So at this junction, we need to now do what we call equating the basis. And we know that there's a law in indices that says if the bases are the same, the powers are equal. So for m, we have the power to be 0, and that should be equal to, on the left hand side we have m's power to be y plus z. Let's leave it at that. For L, we have L on the left hand side. There's an invisible 1 here. So 1, anything standing on this one is having power of 1, because anything raised to power 1 is that thing. So 1 equals to x minus 3y minus z. Then for t, we know that left hand side we have t to be minus 1, and on the right hand side we have it to be minus z. So making z out of the formula, we say divide both sides by minus 1. This will cancel this, minus this will cancel this, and 1 divided by 1 is 1. So z is equals to 1. So let's come here. Let's make y subject of the formula here, so that we have 0 equals to y plus 1. So that if we make y subject of the formula, this one will cross equality sign and become minus 1. So y is equals to minus 1. So since we've gotten z and y, we've gotten z and we've gotten y, let's make x subject to the formula here. So that this becomes 1 is equals to x minus 3 into minus 1 minus 1. Z is 1. So that this now becomes, this 3 is not just 3, it's minus 3. So minus 3 times minus 1 is going to be x plus 3 minus 1. So this is now the sentence saying 3 minus 1, x plus 2 equals to 1. X plus 2 equals to 1. And this is now the sentence saying if these two cross equality sign, it becomes becomes that x is equals to 1 minus 2, which makes x to be equals to minus 1. So that means that I'm left with x to be equals to minus 1, y to be equals to minus 1, and z to be equals to 1. So let's go back. We say remember that v is equals to k r x So when we substitute this, is now the same thing as saying k r minus 1 minus 1 1. That is replacing the variables with their powers, the values we have for it. So applying law of indices, this is the same thing as saying k 1 over r 1 over p. That is small letter p. Some people call it phi. Then times the coefficient of viscosity. So this is the same thing as saying k viscosity all over r p. So this is my answer for expression of v. V is equals to k viscosity coefficient all over rp. So we'll go back to the question. Since we've gotten v using method of dimensional analysis, they say we should get an expression. We should get the velocity of streamline viscosity to obtain an expression for velocity. So that expression that we've obtained is this. So they now give us, given that v is equals to r square. They say given that v is equals to r square p all over 4 coefficient of viscosity L, that we should now obtain an expression for the dimensionless constant, which is k. Now remember that v, from our calculation, v is equals to kn all over rp. So let's put it anywhere we see v now, we'll replace it with this coefficient of viscosity all over r phi equals to r square, and this is capital letter P, that is pressure, all over 4 F. So we are replacing V with this. So to make K subject to the formula, which they say we should obtain an expression for this K, is simply doing cross multiplication. So that this now becomes K So trying to make K subject of the formula, we simply see that we will divide both sides by the coefficients of K, so that this now becomes K is equals to R square P R P small letter p, that is this one is for density, all over Now remember, we can use law of indices to collect this. R square and R is the same as R3. Then capital letter P, small letter p, all over n, that is coefficient of viscosity, n square 4L. So this is our expression of This is our expression of K. This is the answer we have. So, but if we want to solve it using dimensional analysis, now if we want to now get the dimension of what we have here, it's the same thing as saying n raised to power 3. We know that pressure is the same thing that we've gotten before. We've gotten pressure, and the what's it called? The dimension for pressure is simply for pressure is force over area, and that gives us the same thing as saying pressure to be m L minus 1 T minus 2, and density, we have density mass over volume. Density is mass over volume, which is ml minus 3. Let's do this here. Something as saying L3 ml minus 1 T minus 2, density mass over volume, ml minus 3, all over viscosity. Viscosity is simply what did we get for viscosity earlier on? Maybe just earlier on we got viscosity to be ml viscosity to be ml minus 1 T minus 1, and this time is all raised to power 2, then 4L. So, and K is equals to this. So by the time you do the maths, you see that collecting the using multiplication law, you now have that this is L3, this is minus 3. 3 minus 3 is 0. So I'm left with just L raised to power minus 1 up here. L raised to power minus 1. This is M. This is M. 2M. So M square. Then I have T minus 2. So all over. Then here I have M. Then I have L raised to power minus 1. I have L here. This is positive 1. So minus 1 plus 1, 0. And anything raised to power 0 is 1. So I have MT. Okay, sorry. I did not do distributive. I first of all have to do M square. That is distributing this. M square, then L raised to power minus 2. Then T raised to power minus 2. Then 4L. Then 4L. So is at this junction I can now say let's continue to. At this junction I can now say this is now K equals to L raised to power minus 1 M 2 T minus 2 all over M square. This is multiplication. Remember we have 4L here. So L minus 2, then there's L here plus 1, then T minus 2, 4, which is the same thing as saying L minus 1 M squared T minus 2 all over M square minus 2 plus 1 L minus 1 T minus 2 4. Using division law, K will be equals to let's bring the L together. L minus 1 minus plus 1, then M2 minus 2 T minus 2 minus 2 plus 2 all over 4 equals to L raised to power 0, M raised to power 0, and T raised to power 0 all over 4. And this will be the sentence saying, 1 times 1 times 1 all over 4, which is the sentence saying 1 over 4. So our k is simply 1 over 4. If we solve it by dimensional analysis, k is simply 1 all over 4. Thank you.